Today we're going to do lesson 11.2. So this should primarily be review for you. Remember from Algebra 2 or pre-calculus, SOHCAHTOA. And what SOHCAHTOA stands for is if you have a right triangle. So it is important that this is in a right triangle. If I call this angle theta, okay, and theta is just a Greek letter that is typically used to describe an angle. This side is the opposite. This one is the adjacent, and the hypotenuse is always across from your right angle. So what SOHCAHTOA stands for is the sine of that angle. And you do need to have an angle. Every once in a while, I'll have a student who just puts SIN with nothing, and that actually doesn't make any sense because it has to be the opposite of something, and it's the opposite of that angle theta. So sine theta is the opposite side length over the hypotenuse length. Cosine theta, the CAH, stands for cosine theta is adjacent side over hypotenuse, and tangent theta is the opposite side over the adjacent. So we're going to be using that today, as well as our special right triangles. Special right triangles you learned in geometry. So if I have a 45-45 right triangle, the two equal legs are 1. And you could actually do 1 squared plus 1 squared equals c squared. And that's where the hypotenuse, the hypotenuse ends up being the square root 2. So you do need to memorize this, okay? You do have to re-memorize it. I know you did in geometry and when you did Algebra 2. In a 30-60 right triangle, you have, it's called the short leg, the long leg, and the hypotenuse, okay? So there's 2 legs and the hypotenuse, even though there's 3 sides to the triangle. So what's interesting here is if I do the sine of 30 degrees, remember it was opposite over hypotenuse. So sine 30 degrees is 1/2. Cosine 30 is the adjacent over hypotenuse. The sine of 60, so now I'm coming from the 60-degree angle. Now the opposite side is square root 3 over the hypotenuse. And cosine 60 is 1/2. So this should be just a real quick review. You have done this before. So now there's this box with all those values. So let's look at this example. It's labeled example 3. I just cut and pasted from our textbook. So in number 1, if I want to find theta, so I have 4 is the adjacent. Okay, this is the adjacent. And 8 is the hypotenuse. So you want to think about SOHCAHTOA. Adjacent and hypotenuse. What trig function is that? Well, that's the cosine function. So the cosine of theta is 4 over 8. So if I look at my chart above, I should know then that theta is 60 degrees. Number 2, across from 30, that's going to be the opposite, and x is the hypotenuse. So what trig function is opposite over hypotenuse? Well, that's the sine function. So sine theta, well, actually I know the angle, don't I? So let me back that up. So the sine of 30 degrees is 10.8 over x. Well, if you remember your special right triangles, the sine of 30 is 1/2. And so then x is 21.6. So this is how you can use special right triangles. So let's look at example 4. Let me just tell you, this K, and it looks like a hat, that's the way that IB makes the angle symbol. So don't be bothered by that. So in example 4, if it says find angle K, well, angle K is up here. Okay, this is angle K. So from K, 4 is the opposite, and 3 would be the adjacent. So what trig function would I need to use there? Well, opposite over adjacent is tangent. So I would say the tangent of K equals 4 over 3. Now 4 over 3, I would like to think, is that from a 30, 45, or 60 degree special right triangle, and it's not. You don't see any 4 over 3. So then what you're going to do is we need to undo the trig function. So you check your mode, okay? Check the mode on your calculator. Because we're inside a triangle, we do want to be in degree mode. Unfortunately, on our last quiz, I had students that were in the wrong mode and got the wrong answer. So I'm getting 53.1 degrees. Number 2, here's my 38 degrees. So from 38 degrees, 21 is the opposite, r is the hypotenuse. What trig function would I need to use here with opposite over hypotenuse? Well, that's the sine function. So you're going to say the sine of 38 degrees equals 21 over r. You're going to multiply both sides by r, and then divide by sine 38 degrees. So tell me what you get. I'm getting 34.1. All right. So now let's look at example 5. It says a tree casts a shadow of 10 meters when the sun is at an angle of 40 degrees to the ground. How tall is the tree? So I'm going to call the tree H. Okay, let's call that H for the height. So from the 40-degree angle, that's opposite over hypotenuse. What trig function would I use? Well, that's going to be the tangent. The tangent of 40 degrees is h over 10. Multiply both sides by 10 and tell me what you get for h. In word problems, make sure you're including your units. I got 8.39 meters. All right, let's define an angle of elevation and an angle of depression. So the big idea here is that you're always coming from a horizontal line, okay? In order to determine an angle of elevation or an angle of depression, you are always looking from a horizontal line. When you look up from that horizontal line, it's an angle of elevation. From the horizontal line, if you're looking down, it's an angle of depression. Never, ever are you coming from a vertical angle. Once in a while, I'll have students mess that up. So always be looking from a horizontal line. So let's look at example 6. Rondo is flying a kite. The kite string is at an angle of elevation of 60 degrees. So I'm going to go ahead and draw from a horizontal line. This is 60 degrees. If Rondo is standing 30 meters from a point on the ground directly below the kite, find the length of the kite string. So my kite string is X. So let's think here a moment. what trig function would I need to use? Well, I have the adjacent and the hypotenuse, so I'm going to do cosine 60 equals 30 over x. If x is in the denominator of your fraction when you're using SOHCAHTOA, multiply both sides by that variable. And, hey, what's cosine 60? That's one of our special right triangles, isn't it? That's 1/2. Multiply both sides by 2, and x would be 60 meters. Remember that? Cosine 60 is 1/2 from our chart. All right, so let's look at the last topic here. We know that if you have a right triangle, the area is equal to 1/2 the base times the height. But what about triangles that aren't right triangles? So what I want you to do is I want us to look here, and if I'm at angle C, and I want to figure out what the height is if it's not a right triangle. So guess what? I know the sine of angle C equals h over a. And I can multiply both sides by a. So now, if I have area is base times height, well, b is the base, but my height is a sine c. So we would write this as area equals 1/2 AB sine c. So this area formula is used when you don't have a right triangle. It's A equals 1/2 AB times sine C, where here's angle C, and these are the included sides. Or we would say it's side, angle, side condition. So if you look at example 8, this is area equals 1/2 5 times 8 times the sine of 75 degrees. Go ahead and punch that in your calculators. And what'd you get? I got 19.3, and my units are centimeters squared. All right, those are the notes. What I'd like you to do first is go ahead and try these extra practice problems. Then we'll talk about these the next school day. And then for funsies, if you'd like to try this puzzle, I'm not sure that it adds up to, I did not get China's Ming Dynasty year correctly. So you give it a try and we can compare answers. And then start working on the 12-2 homework from the textbook.